How are fiber optic cables joined? When you plan your installation, the fiber cable is generally installed from the communications room to the satellite cabinets or use locations. In many situations with fiber optics, the cable runs are often exposed. For example, in a warehouse, between buildings, or as a building riser. Furthermore, the greater the exposure, the greater chance of damage. So how are fiber optic cables joined when damage occurs? Fiber optic cabling links usually link two separate communication areas, so losing the fiber cable results in losing a whole area of user internet, phones, and Wi-Fi. This is in contrast to a damaged Cat6 cable, for example, when the individual user only is affected. Fiber optic splicing is generally the way to connect two fiber optic cables. This is for new terminations or extending and joining cables. Splicing is also designed to restore fiber optic cables when they accidentally break. In this instance, the broken cable is spliced back together. This is a preferred solution when the available fiber optic cable is conveniently accessible. Currently, fiber optic splicing is extensively used in telecommunications, LAN, local area network, and networking projects. In general, fiber optic splices can be performed in two ways: fusion splices and mechanical splices. Fusion splicing method. Fusion splicing is the stable bond of two or more optical fibers by welding together with an electronic arc. It is the most widely used method of terminating as it provides the least signal loss and the least reflection. In addition, it is the strongest and most reliable joint between the two fibers. When performing this method, fusion splicing machines are used. In general, there are four basic steps in the fusion process. Step 1. The process of splicing starts with the preparation of both fibers. Here you need to take off the protective coating, jackets, tubes, strength members. In summary, leaving the bare fibers exposed. It is noted that the cables must be spotless. Alcohol wipes are used to clean the exposed glass fiber tubes. Step 2. A good fiber cleaver is essential for a successful fusion termination. The cleaver simply nicks the fiber and then causes a clean break instead of cutting the fiber. The end face of the break should be perfectly flat and on the fiber axis. Step 3. When fusing a fiber, there are two main steps: alignment and melting. First, align the fiber ends inside the fiber optic splicer. Once properly aligned, the two fibers are permanently welded together using an electric arc to melt the fibers. This then creates a new continuous fiber core. Step 4. A classic fusion splice has a tensile strength of between 0.5 and 1.5 pounds and is difficult to break through usual handling. However, it still needs protection from excessive bending and pulling forces. By heat shrink tubing, silicone gel, and/or mechanical crimp protectors, there is protection to the splice from exterior elements and accidental fracture. Features of fusion splices. To separate the fibers that maintain polarization, it is also necessary to rotate the fiber of one of them around its axis. Some suppliers make adjustments based on straight camera image and/or optical power throttle monitoring. The latter must have a light source connected to the fiber end, and the other must have a photodetector. Although some fusion suppliers specialize in standard telecom fibers, others can be used for a wide range of fibers. For example, with small or large cladding diameters. For example, there are fusion techniques based on swing electrodes that are suitable for large cladding fibers. A microscope permits the examination of fiber removal quality and position. Often, the view is a look between two orthogonal directions. Fiber cores can also be seen in general. Mechanical splicing method. Mechanical splicing is an optical connection where the fibers are exactly associated and held by a self-assembled assembly, not a permanent bond. This method aligns the ends of both fibers in a common centerline, thus aligning the cores so that light can pass from one fiber to another. There are four basic steps in the mechanical splicing process. Step 1. Fiber preparation is practically the same as fusion splicing. Simply remove protective coatings, jackets, tubes, and power members, so we can see the bare fiber. Then make sure the fiber is clean. Step 2. The process is similar to cleaving fusion splicing. It is important to get a cut on the fiber at right angles to the axis. Step 3. At this stage, we do not use the heating system as an infusion splice. We easily connect the fiber ends inside the mechanical splicing unit. Index matching gel inside the mechanical splice apparatus is helpful because it can connect light from one end of the fiber to the other. Step 4. Once the fibers are connected, we put them in a smooth tray and then put them in a seal. Outside plant shutdown does not require the use of heat. We carefully seal the shrink tubes to prevent moisture damage from the cores. Which method is better? Both methods, including fusion splicing and mechanical splicing methods, have their advantages and disadvantages. we need to choose fusion splices or mechanical splices depending on the applications. The specific reason for choosing one method over the other is economics. Mechanical separation has a low initial investment. However, each connection is a higher cost. The time to complete is also longer, which can add up over a large core count. Although the cost per splicing connector for fusion splicing is lower, the initial investment is much higher. Thus, depending on the accuracy and features of the purchase of the fusion splicing machine. However, the time to terminate each core is considerably quicker and results in less communication loss after the join. Fusion splicing provides a lower level of loss and a higher degree of consistency than mechanical terminations. However, this procedure requires the use of specialist fusion splicing equipment. With that in mind, most industries use fusion splits for longer and higher data rate lines. These rate lines are unlikely to change once installed. Mechanical splicing is often used in these situations. When slices need to be made very quickly and expensive equipment is not available for fusion supplies. Mechanical splices can also be used where splicer machines are hard to access, such as confined space or at heights. Some mechanical fiber optics allows connections and disconnections, so mechanical splice can be used in permanent conditions. Why is it important to use a fiber optic tester in the process of fiber splicing application? The use of fiber optic testers plays an important role in the process of fiber separation. Using visual fault locators, VFL, or optical time domain reflector, OTDR, can help detect where fiber optic cable is damaged and where fiber splicing is needed. Secondly, once the fiber splice has been conducted, a fiber optic tester can be used to check it. Final thought on how a fiber optic cable is joined. Fiber optic splicing is an important method in the installation of fiber optic networks. We need to choose fusion splices or mechanical splices depending on the applications. When you do fiber splicing, you need to follow the strictest guidelines for the perfect supply. Also, it is important to keep all spraying tools clean. For further assistance or a free survey, please email or call on the details below, and click like and subscribe if you have enjoyed this video.